So let's begin with motion in a straight line. So now we'll understand some very basic concepts. Okay, most of these things you might already know, but still we'll do them. Maybe because everybody might not know, right? So let's talk about the position versus time graph first. So suppose this is me and my world is on this straight line only. Okay, so suppose there is nothing else, there is only one straight road. Okay, I live at this place, then I can move on this road only. Okay, so this is motion in a straight line. So I can find everything which I need on this straight road. So suppose I start from this point in the morning and I go for a walk. Okay, suppose I go till the point B, I stop there and I return. Again at point B, suppose there is some newspaper shop or something. Okay, so I go on jogging till that point. There is newspaper shop. I pick up the newspaper. I go till the point C and I stop here. So there might be another shop. Okay, let's suppose tea shop. Okay, so this is the actually this was the thing I used to be doing. Okay, all right. So now I pick up the newspaper here. I go to the tea shop. I order a tea and then I enjoy newspaper and tea. Okay, so now there are some quantities that we can define here. So first quantity is how much is the distance covered. So it's very simple. Total length of the path traveled is the distance covered. Okay, that is one thing. Then second thing is the displacement. So what is the displacement? In this case, the shortest distance, not in this case, displacement is defined as the shortest distance between start point and end point of the motion. Okay, so this is clear. Distance is defined as distance is equal to what? Length of the path traveled. Okay, let me add a page here. Okay, so distance is the length of the path traveled, total length, and displacement is the shortest distance between start point and end point. So this is true for straight line motion. This is true for any kind of motion. Okay, distance and displacement. So suppose this much distance is 100 meters and this much distance is 30 meters. Okay, distance AB is suppose equal to 100. Distance AC is equal, sorry, distance BC is equal to 30 meters. So can you tell me what is my distance covered and displacement in this much motion? Distance is distance is 130, displacement is 70. Right? So this is straightforward. Okay? The shortest distance, that is distance of a line joining start point and end point. This is my displacement. Okay. So then now I want to study this motion. So for that thing, what I do is I plot it on a graph. So this is x line, suppose. Okay, this is x coordinate. So I plot it here. I'm calling this as the position coordinate. And now suppose there is a watch. So nowadays we wear smart watches, right? So there is a watch. Okay. which knows at which point, at what position you were there. Okay, so suppose you know the position as well as the time. So what will you do? You can plot those positions with respect to time to see. For an example, I start from here, okay, and as I just started now, okay, as I just woke up, you can say my energy will be very low, so I will just walk or jog slowly. Okay, so this graph goes like this. Okay, the rate curve you can see. This is point A. This is point A. Then I go to the point B. This is my point B. Okay, and I return from there. So the maximum distance would be how much? It is this much distance AB. Okay, on the position curve. Sorry, position graph. Okay, till what coordinate do I go? Till I start from point A. I go to the point B, and then I return from there. So you can see curve falls downwards. Okay, so time is still increasing, but this curve falls downwards. So see, here I'm starting slowly, my speed is increasing. Okay, again I am stopping at this point, picking up the newspaper. Then again I am okay moving quite fast. Again my speed is decreasing. So you can see here and here the speed is decreasing. Okay, so now we can find out some things from this graph. So what are the things that we can find out from this graph? So we can define, okay, first information that we get, the position at a particular time, right? So suppose I want to find out position at this time. Okay, what will I do? I will just draw a straight line from this point, okay, and it meets the graph at this point. Then I will draw a straight line from there on the position axis. So this is my position at this time. Okay, everybody knows this, right? Yes, no? Okay. Then I can find out my velocity. So what will be velocity? Velocity is the displacement divided by time, right? Velocity is displacement divided by time. So you can say displacement is final position minus initial position divided by final time divided minus the initial time. Okay. So this is suppose t1, the initial time. This is the initial position. Then this is t2, the final time. Okay, and at t2 I can find out my position. So I will draw a straight line from t2 on the graph. It meets at this point. From there I can draw a straight line on the position axis. So it meets at this point. So I was at position C. Okay, so now if I join on the graph, I get these 2 points. Okay, on the graph I get these 2 points. This is this point. Okay, this point is represented by two coordinates. So this is x1 at time t1. This point is x2 at time t2. Position is x2 at time t2. Now if I take difference between the position coordinates, final position minus initial position divided by final time minus initial time, what do I get? I get the velocity. Okay, so velocity is displacement divided by time. And similarly you can find out the speed. So what will be the speed? It is total length of the path, the distance covered divided by time. Okay, so I hope you know this thing, right? Is there a question in this? All right, so now see, let's suppose I take this line. Okay, this is the line joining the initial point and final point, or I can pick any part of the motion. Okay, so let's suppose I pick initial point and this time. Okay, this time. So I will take this point on the graph. Okay, I will join this with the initial point. I will get this straight line. Okay, now let's consider this straight line only. So you can consider the straight line only. Now slope of this straight line will give me the velocity. Okay, so suppose I'm taking time from here to here, but I can choose any part of this straight line to get the slope. Okay, I can choose any part of this straight line to get the slope. So how do we define the slope? Change over the vertical coordinate divided by change over the horizontal coordinate. Okay, so slope is, you can pick any 2 points. So this axis is x-axis, this is time axis. So it is x2 minus x1 divided by t2 minus t1. Okay, so if you see it here, this is my x1 t1, this is x2 t2, and this is x3 t3. Okay, so I will get the same slope. If I take x3 minus x2 divided by t3 minus t2, or even if I take, okay, I choose any 2 points on this line and I take difference between the coordinates, okay, vertical coordinates divided by difference between the horizontal coordinates, I will get the same slope, right? So this is how we define the slope. How do we define the slope? So it is defined as rise over the run. Okay, rise means the change over vertical coordinate, run means change over the horizontal coordinate. Okay, this is how we find the slope. And now the slope, it gives us velocity, and there is one more thing about the slope. So see, this line and horizontal, they are inclined at some angle theta. So if you find out tan of theta, it will give you this slope. Okay, slope is equal to tan of theta. So see here, if you choose these 2 points, okay, this vertical distance will be equal to what? It is x2 minus x1, right? This vertical distance is equal to x2 minus x1, and the horizontal distance is t2 minus t1. Okay, so if this angle is theta, then what will be tan of theta? The opposite side, which is equal to x2 minus x1, divided by the horizontal side, which is equal to t2 minus t1. Okay, this thing is clear. So we studied motion a little bit. Next, let's see some types of motion. Okay, next let us see some types of motion. So what are types of motion? So we can say one kind of motion can be uniform motion, when your velocity is constant. The other kind of motion is non-uniform motion, when your velocity is changing. Okay, or you can say speed. In uniform motion, your speed will be constant. In non-uniform motion, your speed will be changing. Okay, so now here we define the speed, which is distance upon time, the velocity, which is displacement divided by time, and we can define the acceleration. What will be the acceleration? Acceleration is change in velocity divided by time. Okay, and if object is moving in the same direction, it's not changing the direction, then the acceleration will be equal to what? It will be change in speed, you can say, divided by time. Okay, so there is some difference in these two statements. So first one is, okay, as I said, acceleration you can define as change in velocity upon time, and so this is true for any case. Okay, it is change in velocity divided by time. Now if your object is moving in a straight line and it's not returning, okay, then you can define its acceleration as change in speed divided by time. Is it clear? Yes, no? Okay. So now acceleration we can define as final velocity minus the initial velocity divided by time. Okay. So suppose v1 is the velocity at time t1, v2 is velocity at time t2, then we can find out acceleration as this velocity v2 minus v1 divided by time t2 minus t1. Okay, or we can say this difference between two times is equal to small t. Final velocity we denote as v, initial velocity in general we denote as u, So acceleration is equal to v minus u divided by t. Okay. So from this we get our first kinematic equation of motion. It is v equals to u plus at. If we move this t on this side, u on the u also on that side, so you get v equals to u plus at. This is your first kinematic equation of motion. Okay. So now see, let us see some problems, very basic problems. Okay, that don't require any detailed theory. Okay, so let's see this problem. Find the average velocity when a particle complete find the average velocity when a particle complete the circle of radius 1 meter in 10 seconds. So can you tell me? It's option D, right, Ganga? Okay. What will be average velocity? So first of all, this is not straight line motion, but here we don't need anything else. We don't need to know about directions, etc. to solve these kind of problems. Okay, so that's why I included them. This is general. Okay, so particle completes one revolution in a circle. So suppose it starts from this point, okay, and it comes back to the same point. Okay, it starts from the same point, comes back at the same point. Then how much will be your average velocity? So displacement is equal to 0. Velocity is displacement divided by time, right? So displacement is 0 and therefore velocity will be equal to 0. Okay, is it clear, Ganga? Okay. Let us see next question. A runner starts from 0 and goes to 0 following path PQRO. So sorry, OQRO in 1 hour. What is net displacement and average speed? So it starts from here, point O, it goes to Q, then it goes to R, and it goes back to O. So what is net displacement and average speed? This is the question. So what is net displacement? This we know, right? Net displacement is 0 because it is starting from some point and it is also ending at the same point. Okay. Then what is the average speed? So to find the average speed, we have to find out the total length of the path. Okay. So speed is equal to what? Distance upon I'm sorry, distance divided by time. So time is 1 hour. Distance covered would be equal to this much distance plus this distance plus this distance. Okay. So I can say distance from O to Q plus distance from Q to R plus okay distance from R to O. So how much is this distance? This is radius. Okay, this is equal to radius plus how much is this distance? So you can say length of this arc will be 1/4 of circumference of the circle, right? So it will be 2 pi r upon 4. Okay, plus what is RO? So it is also equal to r, right? So this is distance covered divided by time is 1 hour, and because all the options are in okay kilometer per hour, so we don't need to care about that. So it is equal to okay divided by 1, right? So it will be r plus r. Yeah, you found out? It's option A. Let's check. 2r plus this will be 2 by 4 is okay. This is pi r upon 2. Okay. So then how much is the radius? It's 1 kilometer. So you can take r common. It is 2 plus pi by 2 multiplied by 1 kilometer per hour. Okay. So 2 plus pi is 3.14 divided by 2 is 1.57. So right, it is 3.57. This is the answer. Option A. Okay, so this is very simple problem, right? Okay. Next question. A wheel completes 2000 revolutions to cover the 9.5 kilometer distance. Then the diameter of the wheel is. Okay, so this is slightly different question. Can you tell me what should we do? It completes some revolutions, 2000 revolutions, right? And it covers some distance. Can you guess? Oh, this is not, looks like egg. This is a wheel and it moves from this point to this point to this point. Okay, so this much distance, it covers some distance. Let's call it x. X is equal to 9.5 kilometers. Okay, and now it completes 2000 revolutions while doing so. So, good morning, Anirudh. Okay, so now can you guess what to do here? Okay, so distance covered in some n revolutions is given. Can you find out distance covered in one revolution? So if you mark some point, if you mark some point on this wheel, let's call this point A. Okay, as the wheel rotates, okay, it moves on the ground, it rotates, right? So this point will go up and it will come back to the same position. Same position meaning it will again touch the ground. After how much distance? So distance equal to, when distance is equal to 2 pi r, right? When distance is equal to circumference, it will again touch the ground. So in one revolution, it will cover distance equal to 2 pi r. So in n revolutions, it covers some distance. It will be equal to n times of 2 pi r. Okay. So I can say distance covered in n revolution is equal to n times of 2 pi r. Okay. So s is equal to n times of 2 pi r, right? This should be our formula. And I want to find out diameter, that is 2r. So I will take n and pi on other side. So diameter, which is equal to 2r, will be equal to what? Distance covered divided by n pi. Okay, so distance covered is 9.5 kilometers. Answers are in, okay, some of them are in meters, some one is in kilometer. Let's convert this to in meters. Okay, because we have option D, you said. Okay, let's check. 9.5 multiplied by 10 raised to 3, and this is 2000. Okay, or 2 multiplied by 10 raised to 3 multiplied by pi. Okay, 10 raised to 3 and 10 raised to 3 gets cancelled. This is 3.14 times 2 is 6.28. So 9.5 divided by 6.28 is the answer. It cannot be D. Roughly you can say 9 divided by 6. B. You said B? Okay, good. So it's option B, right? Is it clear, Raghu? Okay, good. Next question. A cyclist moving on circular track of radius 40 meter completes half revolution in 40 seconds. Its average velocity is, can you guess? All right. Cyclist moving on circular track of 40-meter completes half a revolution in 40 seconds. So you have to find out whenever velocity is asked, you have to find out the displacement, right? What will be its displacement in half revolution? Suppose it starts from this point. It is option D. Let's check. So this is A, this point is B. It goes from A to B, right? So this much would be displacement. Okay. Length of arc AB is displacement. It will be equal to pi r. But what is the distance? I'm sorry. This much would be the distance covered, not displacement. Okay. Length of the arc is distance covered. What would be displacement? This distance. Okay. Straight line distance from A to B. That is displacement. Right? So displacement is equal to its diameter, which is equal to 2r. Okay. And time is 40 seconds. So therefore the velocity is equal to what? 2r divided by 40. Okay, so it is 2 times 40 upon 40. So answer is 2 meters per second. So option B. You said B, Ganga? Okay. Anyways, so if you miss this thing, your answer would be different, right? Okay. So this is clear. Simple question. Okay, good. Let's see next question. Okay. So here I have okay written down the answer because we are deriving a formula here. Okay. So see, these kinds of questions are repeated in different exams and it can be there in NEET also. So let's understand this question. Car covers the first half of the distance between the two places at 40 km per hour and another half at 60 km per hour. Okay. So the distance between two places, it covers first half of the distance. So suppose car starts from this point, it covers half of the distance. Okay. So total distance is suppose total distance is S. It covers S by 2 with the speed of 40 km per hour and remaining half with the speed of 60 km per hour. Okay. The average speed of the car is. So let us understand this question. Okay. We'll get the formula and then from next question onwards, if there is a question based upon this, we can use that formula. Okay. So see, what is the average speed? It is the distance covered divided by time. Total distance, which is S divided by total time. Okay. So now, suppose this car covers first half of the distance in time t1, covers this much distance in time t1. Next half of the distance in time t2. Okay. This much distance in time t1, this much distance it covers in time t2. So denominator will be equal to what? It will be equal to t1 plus t2. Okay. So we have to find what will be that t1 and t2. So it moves from A to C with velocity v1, with speed v1, which is 40 km per hour, and C to B with 60 km per hour. That's v2. Okay. So we know what is speed. It is distance covered divided by time, right? So v1 will be equal to this speed will be equal to this distance, which is s by 2 divided by time t1. So you can find out t1. T1 will be equal to s by 2. Okay, s by 2 divided by v1. You take v1 on the other side. Similarly, you can find out t2. T2 will be equal to s by 2 divided by v2. Okay, distance upon speed, right? It's the time. So you got t1, you got t2. Put it here. So you will get t1 plus t2, right? So t1 is equal to, take this 2 in denominator. It is s upon 2v1. Okay, it is s upon 2v1 and this is T2 is equal to S upon 2V2. Okay, S and S will get cancelled with this. Okay, S in numerator, I mean you can take this S common and cancel it out with this S, and after that you can find out average speed. So V average will be equal to what? 1 upon 2V1 plus 1 upon 2V2. Okay, so it is 1 upon 2V1 plus 1 upon 2V2, right? So here we can make the denominator of denominator same. So here we can multiply with V2, okay, to numerator and denominator. Here we can multiply with V1 to numerator and denominator. Okay, so if we multiply this term with V2, this term with V1, so denominator will be 2V1 V2. Okay, it is 2V1 V2. This will be V2. Okay, 1 times V2 is V2, 1 times V1 is V1. So V2 plus V1 divided by 2V1 V2, right? So then you can take the 2V1 V2 in the numerator because it is in denominator of denominator. Okay, it's in denominator of denominator, take that to numerator. So you get V average is equal to 2V1 V2 divided by V1 plus V2. So is this thing clear till this point? Okay, so now you can substitute V1 and V2. You can substitute V1 and V2 and you can find out the answer. So V1 is 40, V2 is 60, right? V1 is 40, V2 is 60. So it is 2V1 V2 divided by V1 plus V2. So 40 times 60 multiplied by 2 upon 40 plus 60 is 100. So its answer comes out to be 48 km per hour. Okay, this is answer of this question, 48 km per hour. Okay, so it is for this question. This question we took to understand this formula. Okay, so what is the formula? So if you have, let's suppose you have a car which covers some distance s with different speeds. Okay, what are those different speeds? So in first half it goes with the speed v1, in second half it goes with the speed v2. Then now what will be the average speed? So you have this formula. Okay, actually before this we arrived at this formula. Okay, so if you take reciprocal of this thing, you will get 1 upon 2v1 plus 1 upon 2v2. Okay, so you have this formula 1 upon v average is equal to 1 upon 2v1 plus 1 upon 2v2, right? If I take reciprocal of this formula, this one, take reciprocal, what will happen? This is 1 upon something, so that something will go to numerator, and here reciprocal of V average will be 1 upon V average, right? So you get 1 upon V average is equal to 1 upon 2V1 plus 1 upon 2V2. So this is the formula that you have to remember. So this is the formula that you have to remember. Okay, is it clear? Yes, no? Okay, but this is just for the case of if your car covers first half distance with some speed, next half distance with some other speed. Okay, now your car can cover the total distance in three parts. Okay, first one third distance s upon 3 you can say with speed v1, second distance, okay, second one third distance with speed v2, third one third distance with speed v3. So then will this formula work? I'm sorry, will work or not? It will not work. You need new formula. What will be that new formula? So now I hope you can, okay, imagine this. I will just make this short. Our new formula, if there are three distances, right, s by 3 with speed v1, next s by 3 with speed v2, and next s by 3 with speed v3. So your 1 upon v average will be equal to 1 upon 3v1 plus 1 upon 3v2 plus 1 upon 3v3. This will be your formula. Got it? Okay, if it covers distance s by 4 in with speed v1, s by 4, next s by 4 with speed v2, next s by 4 with speed v3, and next s by 4 with speed v4, then your formula will be 1 upon v average equals to 1 upon 4 v1, because the total distance is broken in 4 parts now. Okay, so this much distance with speed v1, this much distance with speed v2, this much distance with speed v3, and this much with speed v4. So total distance is broken in 4 parts. 1 upon v average will be equal to 1 upon 4 v1 plus 1 upon 4 v2 plus 1 upon 4 v3 plus 1 upon 4 v4. Got it? Yes, no? Okay. So your generalized formula will be this one. See this formula. Total distance is divided into n parts. N can be equal to 2, n can be equal to 3, n can be equal to 4, 5. Okay, it doesn't matter, right? What will happen? 1 upon v average, if the total distance is broken in n parts of same length, right? And those distances, those individual distances are covered with speed v1, v2, v3, etc. Okay, so your 1 upon v average will be equal to 1 upon n v1 plus 1 upon n v2 plus 1 upon n v3 plus so on and so forth 1 upon n vn. This is your formula. Got it? Is the formula clear? Okay. So you have to memorize this formula. Then depending upon whether n is equal to 2, 3, 4, you can, I mean in exam there is a question, you can change the formula. Change meaning what? You need to consider only that many terms, right? For n equal to 2, you will have two terms. Okay, 1 upon 2 v1 plus 1 upon 2 v2. For n equal to 3, you will have 1 upon 3 v1 plus, okay, 1 upon 3 v2 plus 1 upon 3 v3. Okay, so depending upon n, you will have n terms in this formula, right? So this is the formula that you should memorize. Okay, now next question. This is from NEET. A person traveling in a straight line moves with a constant velocity v1 for a certain distance x and with a constant velocity v2 for next equal distance. The average velocity v is given by the relation. Tell me. It's option B, right? So what they have done is, our formula is 1 upon v average is 1 upon 2 v1, okay, for two distances, two equal distances, plus 1 upon 2 v2. So just take this 2 common, move it here, okay, you will get this option B, right? Clear, Ganga? Okay, good. Let's see next question. A car moves x to y with uniform speed vu and returns to y with uniform speed vd. Okay, it returns to x actually. There is a print mistake here, typo. Okay, it moves from x to y, then it returns to x with speed vd. Average speed for this round trip is, tell me. It is option A, right? Actually, they are asking the same thing. Okay, so this is similar. See, you will say, okay, maybe some student might say it's not like it goes from okay, it covers distance s, it goes first half with some speed, second half with some speed. It is going to some distance and it is returning back. Still this is applicable, right? Because first half distance is covered with speed v1, next half distance is covered with speed v2. Okay, so it's the same question actually. So its answer is option A, same answer, right? Okay, so this question is from CBSE AIPMT, which was the earlier name of the NEET, you can say. Okay, right. So now I just want to mention specific cases. Maybe there, okay, I'm not taking a problem. Okay, I'm making problem here itself. Okay. So now suppose car covers one third of the distance from x to y with speed v1 and remaining distance with speed v2. What is the average speed of the car? This is my question. Okay. One third of the distance with speed v1 and remaining distance with speed v2. So now what will you do? So I will not explain. Okay. So actually you can do it in two ways, but I want you to do it in only one way. So see, this is okay, which is the fastest way. So see, you have this car which moves from here to here. It covers one third of the distance s by 3 with speed v1, okay, and remaining this much distance with speed v2. So what will you do? So once again, I can apply the same formula. Okay, don't need to change anything. I can apply the same formula. So this kind of question I will solve like this. See, 1 upon v average will be equal to 1 upon, see, now what I will do is this distance is 2s by 3. So I will divide this one also in two parts. Okay. So now distances are s by 3, s by 3, s by 3. It is 1 upon, okay, 1 upon 3v1 plus 1 upon 3v2 plus 1 upon 3v2, right? So for this part and this part, your speed is same. Okay. It's v2 only. Clear? If it is moving from here to here with speed v2, that means it moves from here to here with speed v2, from here to here also with same speed v2. Okay. So your 1 upon v average will be, use same formula, 1 upon 3v1 plus 1 upon 3v2 plus 1 upon 3v3, but v3 will be equal to what? v2 only, because it's moving. So then this is your 1 upon v average. So this will be equal to 1 upon 3v1 plus this is 2 upon 3v2. Okay. Then you can do, if you like, cross multiplication, etc. Okay. And you can find out the answer. So if you do cross multiplication, it will be 3v1 v2. So this will be v2 plus 2v1 divided by 3v1 v2, and this is 1 upon v average, and you want v average, so it will be reciprocal of that, 3v1 v2 divided by v2 plus 2v1. Okay. So let me just take this on next page because question is here. Oh, okay. And then, as I said, you can take v average equals to 3v1 v2 divided by v2 plus 2v1. Is this clear? Okay. So this is the shortcut, right? Okay. Now otherwise you will have to find out time for this one, time for this. Okay. Time for this one, then total distance upon total time, and then you will come to the formula, right? The answer. Okay. So this is how you can solve these kind of questions too. Okay. Using the same method. Oh, okay. Similarly, now, okay, similarly, see, now suppose distance s by 4 is covered with speed v1. Distance, remaining distance is covered with speed v2. So what will you do? You will write, okay, this is s by 4. So remaining is equal to 3s by 4. 3s by 4, right? This is 1/4. So remaining is 3/4. So I will say this is, okay, my average velocity will have this formula 1 upon V average is 1 upon 4V1, because total distance can be covered. Okay, total distance can be broken in 4 parts. Okay, this is S by 4. So remaining distance I will break in 3 more parts. So 1 upon 4V1 plus, okay, you can directly write it is 3 times 4 upon V2. Sorry, 3 times 1 upon 4V2. Okay, or you can say 1 upon 4V2 plus 1 upon 4V2 plus 1 upon 4V2. Okay, which will be equal to 3 times 1 upon 4V2. And then you make the denominator same, and what will you get is V average is 4V1 V2 divided by V2 plus 3V1. Okay, so is it clear? Is there a question? This type of questions you will be able to solve, okay, very simply. All right. So then let's talk about the uniformly accelerated motion. So what is uniformly accelerated motion? Uniformly accelerated motion means object starts with some velocity, some initial velocity, and it keeps on accelerating with a specific rate. Okay, its acceleration is constant. A is constant. Okay, its velocity is changing, but changing with a uniform rate. That is uniformly accelerated motion. So now, if I want to plot the velocity versus time graph of a uniform motion, the graph will look like this. Okay, motion is uniform. That means velocity is constant. Okay, velocity is constant. So graph will be like this. If I want to plot the velocity versus time graph of the uniformly accelerated motion, the graph will look like this. So velocity is changing, but that change is uniform. Okay, so you will get a straight line. Okay, this kind of a straight line curve. So I can say this is also uniformly accelerated motion with some acceleration. Can you tell me that acceleration? Very simple. See, here acceleration is equal to 0, right? Okay. So this is also uniformly accelerated motion, but acceleration is 0. Okay, right? Acceleration is what? Slope of velocity versus time graph. So just like we discussed velocity is slope of position versus time graph, acceleration is slope of velocity versus time graph. Okay, so acceleration is final velocity minus initial velocity divided by time. So now see, we have to remember the graph will look like this. This is for uniformly accelerated motion. This is the velocity versus time graph. Okay, and we have to remember the equations of motion for uniformly accelerated motion. They are known as kinematic equations of motion. Okay, they are known as what? Kinematic equations of motion. So here I have derived them. Okay, the 3 equations. We just have to remember. Okay, no need to care about the derivations. Okay, so what are those 3 equations? So first one, kinematic equations. Kinematic equations are, we know them. Okay, we have been studying, if I say from ninth standard. Okay, so first one is V equals to U plus AT, right? Okay, second one is S is equal to UT plus half of AT square, and third one is equal to v square equals to u square plus 2as. Okay, so here I have used different notations, right? So u is your initial velocity, a is acceleration, t is time, v is final velocity. First kinematic equation is v equals to u plus at. Then s is the displacement. So displacement is ut plus half at square. And third one is v square, final velocity square is equal to u square plus 2as. Okay, u is initial velocity, a is acceleration, and s is the displacement. So these are the three equations, kinematic equations. Okay, and we have to memorize these equations, right? So do you know these equations? Okay. Now, no need to care about the derivations, okay, particularly for these equations. So last derivation I explained because there was some method and we wanted to use it differently for different questions. Okay, so here these formulae they will be same. Okay, there is no method which we need to use. Okay, so we just have to memorize these equations. Then let's move on to the next topic, which is Galileo's law of odd numbers. Okay, so this is a simple trick which we can use to solve problems based upon uniformly accelerated motion. So for an example of uniformly accelerated motion is if you release something from some height, it will fall on the ground. With what acceleration does it fall? We call that acceleration due to gravity. What is its value? 9.8 meter per second squared, right? So this is an example of uniformly accelerated motion. Acceleration is uniform. Okay. So now Galileo's law of odd numbers says the distance is covered in equal times. Okay. Distance is covered in equal times by an object which is performing uniformly accelerated motion are in the ratio of 1 is to 3 is to 5 is to 7, so on and so forth. That's why law of odd numbers. Okay. For an example, you release something, you release this ball from some height. Okay. And in some time it falls on the ground. In some time it falls on the ground. So here see the ground. So in some time t1 oh t1 equal to t covers some distance. This is s1. In same time it covers some more distance. Okay, this is suppose s2. So this is in time t2 which is also equal to t. Let's suppose t is equal to 1 second. In 1 second it falls with distance s1, and next 1 second it falls with distance s2, in next 1 second it falls with distance s3. Then this s1 is to s2 is to s3. Okay, if it has not reached the ground yet, will be equal to what? 1 is to 3 is to 5. Got it? Yes or no? Okay, so this is Galileo's law of odd numbers. We have to remember this, and now we can solve some problems, okay, based upon this. So a ball is thrown vertically downward with a velocity of 20 meter per second from top of a tower. So this is based upon uniformly accelerated motion. A ball is thrown vertically downward with a velocity of 20 meter per second from top of a tower. It hits the ground. After some time, the ball hits with velocity 80 meter per second. The height of tower is. So tell me which equation we can use here. U is given 20 meter per second. V square minus u square equal to 2as. V is given and a is 10 meter per second square. We want to find s. So 2as is equal to v square minus u square, and s will be equal to what? Take that 2a on the other side. So s is equal to v square minus u square divided by 2a. So v is 80, 80 square minus 20 square. Okay, good, good. So let me just cross check, right? This is, you can say, 4 times of 20 square minus 20 square. So it will be 1520 square. Okay, because this will be 1620 square, will be 20 square. 1520 square upon 20. So it is right. 15 times 20, 300. Option D, good. Okay, this is very simple question, and okay, I can say 9 standard question, and they are still asked in NEET. Okay, right. Next one, stone falls freely under gravity, covers distances h1, h2, h3 in first 5 seconds, next 5 seconds, and next 5 seconds respectively. The relation between h1, h2, h3 is. So tell me, this is a direct question. It is option D. Okay, let's check. So h1 is to h2 is to h3, because they are covered in same time, and this is uniformly accelerated motion. It will be 1 is to 3 is to 5. Okay, then I can say h1 upon 1 will be equal to h2 divided by 3. It will be equal to h3 divided by 5. Okay, this one divided by 1 is equal to this one divided by 3 divided by this one divided by 5, and it is precisely the option D. Okay, so this is clear. Okay, so if you know this law, you can solve this in, okay, very quickly in 30 seconds or something. If you don't know this, you will need half an hour. Okay, so if you don't believe, I have one video on my channel. I'm explaining the Galileo's law of odd numbers. I'm deriving it. Okay, so you can check how much time does it take. So you need to know it, because there can be direct questions and there can be some indirect questions which we can solve using it. Okay, so next question. A boy standing at top of a tower, a boy standing at the top of a tower 20-meter height drops a stone. Assuming g equals to 10 meters per second square, the velocity with which it hits the ground is. Tell me. Option B. Okay, so height is given and g is given. So which formula? Okay, right. V square equals to u square plus 2as. Okay, but u will be equal to 0 because it just drops it. Okay, so initial velocity is not given. That means it is 0. Plus 2 times g is 10 multiplied by s is 20. So this is 20 square. No, it's not option D. You said B or D. Okay, okay. Sorry. B for Bombay. Okay, so V is equal to 20. Right. It's option B. So another straightforward question. Okay. Let's see next one. And you tell me this. A particle starts its motion from rest under the action of a constant force. If the distance covered in first 10 seconds is s1, that covered in first 20 seconds is s2, then. Tell me. This one is slightly twisted. Okay, yes. Option D. D, right? D for Delhi. Okay. All right. See, this question also based on it is also based on the Galileo's law of odd numbers. I mean, not based, but if you know the law, you can solve it very quickly. So they're saying distance covered in first 10 seconds. Okay, distance covered in first 10 seconds. This is the distance. Okay, S1 is equal to distance covered in 10 seconds. So it's in time t1. Okay, in 10 seconds. And this much distance is covered in 30 seconds, sorry, 20 seconds. So this is S2. S2 is covered from here to here. It's covered in 20 seconds, right? So this is the S2 minus S1. So let's call this distance as X. So from here to here, it comes in 10 seconds. From here to here, it comes in 20 seconds. How much time will it take to come from here to here to cover the distance equal to X? 10 seconds, right? Right? Yes, no. Okay. So X in 10 seconds. So now I can say that the total distance S2 is equal to X1 plus S, sorry, S1 plus X. So how much will be X? Now S1 and X, they are covered in same time, 10 second, 10 second. So X is equal to 3 times, 3 times of S1, right? Because ratio is 1 is to 3 is to 5 is to 7, right? So this is 3 times of S1. So it is S1 plus 3 times S1. So it is 4 times of S1. This is the answer. Option B is the answer. Got it? Okay. So you can, if you don't know the law, you can still solve this. It will need some time. Okay, not as much as this question, because here 3 distances are covered, sorry, compared. So it will need some 5 minutes or something. Still you can solve this one. Okay, but anyways, we know the law, we are going to use it. Okay, next question. A ball is dropped from a high rise platform at t equals to 0 starting from rest. After 6 seconds, another ball is thrown downwards from the same platform with a speed v. Two balls meet at t equals to 18 seconds. What is the value of v? Okay, so this is slightly different. A ball is dropped from high-rise platform at t equals to 0 starting from rest. After 6 seconds, another ball is thrown. It is thrown down. So first one is dropped, second one is thrown. Okay. Two balls meet at 18 seconds. So first one is getting total time equal to 18 seconds, and second one it is dropped after 6 seconds, so it gets time equal to 12 seconds to cover whatever distance it covers. Okay, what is the value of v? Okay, so second one is dropped with speed v. So we can say, right, we can say the distance covered will be equal. First one is dropped, After 6 seconds, second one is thrown from the same position, but they meet somewhere. So distance covered will be equal. Okay, so I can say S1 will be equal to S2. Okay, first one is just dropped, so you can say U1. Okay, this is just ut plus half at square, u1t plus half of g t square. Acceleration will be equal to g. Okay, but u1 is 0, so this thing is just half of gt square. For second one, it is okay, u2 times t, u2 is its speed, initial speed, plus half of g times t2 square. Okay, this is times are different. First one is getting whole 18 seconds, second one is getting 12 seconds, right? So yeah, we want to find u2. So let's put the values. Okay, this is little bit of calculation. u2 times t2 will be equal to, you can say, half of g multiplied by t1 square. You take that on the other side, half g minus half g into t2 square. So you can take half g common. Okay, I can take half g common. T1 square minus T2 square. 75. Let's check. So this is 10 by 2. 18 square, I don't know. What is 18 square? 12 square, I know. Is it 256 or something? Okay, I can do one thing. Okay, this is a square minus b square. 324. Okay, 256 is 16 square. Wait. Okay, so this is 5 times 324 minus 144. This will be how much? 180? 180, right. So 180, and T2 is 12, so move that 12 on the other side. Okay, so 12, 15 12s are 180, right? Okay, so this is 15 times 5, right? 75 meters per second. Okay, all right, so its answer is option A. Now suppose I don't know 18 square. What will I do? I can still solve it. Okay, actually very easily. So I will use formula of a square minus b square is a minus b, a plus b. Okay, so it is 18 minus 12, 18 plus 12. Right, so this will be 6, and this will be what? 18 plus 12 is, it is 30. Right, so answer is how much? Yeah, so you don't have to do this subtraction. Instead of that, you are doing a minus b, a plus b. Okay, still you get the same answer. Okay, all right, so is this question clear? Okay, good. So this one was last question based upon this thing.